The HVDC has two poles, named Pole 2 and Pole 3. When both poles are available, the HVDC link can be used to full capacity, 1,200 megawatts north and 850 megawatts south. With both poles, the HVDC link operates in round power mode. This means that the power transfer can smoothly pass through 0 megawatts and change direction from north to south and vice versa. Outages on one pole reduce overall capacity and remove round power capability. The remaining pole is physically subject to a pole minimum transfer level. This is 35 megawatts for pole 3. This means pole 3 must be dispatched to transfer at least 35 megawatts south, 0 megawatts when it's off, or to transfer at least 35 megawatts north. In the forward schedules, in order to normalise the pricing between the two islands, pole minimums are not modelled. In the RTD schedules, as assets cannot be dispatched outside their declared capability, the pole minimums are modelled. In a monopole scenario, the system coordinator checks the forward schedules for the HVDC transfer forecast, which is compared against actual inputs, as they will vary. For example, the forward schedule may indicate a north transfer of 40 megawatts, indicating that the HVDC will remain in north transfer. However, if actual North Island intermittent generation is 25 megawatts higher in real time than what is forecast in the forward schedules, then the actual HVDC north transfer will be lower than the forecast transfer. When operating in monopole, the system coordinator must check if the actual transfer would be below the pole minimum. In this example, the actual transfer would be 15 megawatts, which is below the minimum transfer of 35 megawatts for pole 3. So, the system coordinator must decide whether to keep the pole on at 35 megawatts north transfer or shut the pole down. Let's look at the impact of either discretion on the market. The HVDC is unconstrained and operating in monopole. The marginal price for both islands is the same. The forward schedule shows 15 megawatts north transfer, which is not physically possible with only one pole. So the system coordinator must decide to apply a discretion to either keep the transfer at the pole minimum of 35 megawatts north or shut the pole down. Option 1, keep at 35 megawatts. When keeping the pole on at 35 megawatts north, more expensive South Island generation is dispatched on, while some cheaper North Island generation is dispatched off. This leads to a price separation between the two islands. This price separation will be immediately visible following the RTD dispatch. When using discretion to turn the HVDC off, more expensive North Island generation is dispatched on, while some cheaper South Island generation is dispatched off, so the prices in the North Island rise, while prices in the South Island will be lower. Again, this price separation will be immediately visible following the next dispatch. So, depending on the discretion applied, it will impact the North Island and South Island marginal prices differently.